Assalamualaikum warahmatullahi wabarakatuh. Good day, everyone. My name is Tariq Putri Ali. Uh, in this video, I want to talk about uh, my final project of cybersecurity. In this case, it's digital forensics. Uh, in, yeah, the purpose is to fulfill the final project of the cybersecurity courses. Okay. First of all, let's see what the evidence got. So we have in this case, we have the RQ, uh, which means my USB drive. Uh, in this type is USB drive. The file system is FAT32. Yeah, neat. Your space is 36.3 megabytes, and the free space is 28.8 gigabytes. So yeah, for the usage, I'm using For the usage of the drive, I'm using the Toshiba Transmemory USB drive. Yeah, this is Scarlett, not yeah. This is Toshiba. For the USB drive. Yeah. For the details is right here. Driver is my 2006, and the driver version is 10.18.360.1. Okay. So in this case, I managed to contain four files. First of all is these GIF files. So it contains the Hatsune Miku's without food. Yeah, this in this case is this GIF G, GIF files. So the next one is this. This is the image file. Uh, Copyright to Jonathan Ross in the art station. The next one is Neko Hacker. Yeah, copyright. Uh, yeah, copyright from for Neko Hacker. And the last one is rundown. In this case, this is the file, the rundown of the uh, predated outdated UKM fair. So, in this video, I want to talk about the how to generate the pre-deletion and after deletion of the file. How about the hash? How about the my perspective of evidence that I got, and the goals is also derived. The goal and the result of my process are two. The first one is are the data can be that have been deleted still giving out the same result. In my case, it's corrupt or reserved or have the etc etc, and are the data giving out the same checksum. Okay, first of all, yeah, we need to delete this file. Yeah, okay. Uh, in this case, we have to open the access data FTK imager. Uh, so the first one is we going to FTK imager first. In this case, I use 3.1.2.0 version, and we create this image. And in this part, we need to select source of the evidence type. We have there are physical drive, logical, image, and contents. In this case, I'm using the logical drive for the evidence type. Next, in this next section, we have source drive section. So we have the G, which is the source of the dummy files or the evidence files. So as we can see right here, there's RQ and the FAT32. We click finish, and then voila, there's the create image source, and we have no image destination. So what we need to do is add this, because we have to start start it, and we cannot do it until the image destinations is derived. So we need to add, and then there's image type. For the image type, there are four: raw, smart, E01, and AFF. So in my case, I'm using the raw or DD. Okay. Evidence item information. We have this type of information. So there's case number, evidence, unique description, examiner, and notes. So uh, for this record, I'm using case number 001, and evidence number is 001, and the unique description is FD evidence RQ, and the examiner is myself, Torik Putra Renaldi. So in the notes, we can leave these notes, but in my case, I'm using the notes is for recording. Although I have the image file in pre-record, so this is just for the step by step how to use the FTK imager. And then we click next, and then there's a select image destination, image destination folder. We can browse it, whether it uh, where is going to be saved. So in this part, we have pre-deletion and new folder. For this case, we choose new folder, and the file name is recording evidence. Okay, so that's it for the image destination, and then we click finish. So there are several types that it's been completed. So for this case, we don't use to create directory or pre-calculate progress statistics, or yeah, we just unclick or a click. Never mind. So we click start. On my case, we have I have already do the pre-recorded image. So we just click and cancel, and then yeah, failure. So in this case, yeah, uh, there are wait, where is it? So the detail of the my evidence is 32 minutes. For yeah, it takes a long time because uh, it takes a flag and a lot of HD files the to become the image. So yeah, and there's the evidence of the USBs. So sector 10 predilation evidence USB 001 and sector count, etc., and the verify result is match, and the verify result is matched in SHA1. So my case is that this already done, and we have already done this too. Yeah. So what if we have what if I delete this permanently? So there's nothing. And yeah, uh, in here, how to restore it, how to take the image pre-record image file from the evidence items. So we select the logical drive, yeah, and then we have to take the G and then finish. There is some case here, so there is like there, well, there's so many, yeah. there's so many. There is image one, image one, image one. Okay. Yeah. So as we can see that this this date modified. So so as we can see that there are several types. Yeah. That it can run the rundown acara with the uh, better place, the better hash sum, hash sum. Yeah, sorry. And there will be several Neko hackers that I deleted recorded before the recording session. And there's the GIF file, and yep, yep, there it is. There's the GIF files, and this is the image file too, and this is the Neko hacker. So, as we can see that this is bit deleted. So six that modified is this 2019. I don't know why, but yep, seems legit. And this type is the regular file, the random file, the yeah, this is the GIF. This is the broken file, and this is the can be run. So in my case, what can I expect is that so goal results of my evidence from the hashes comparison above, we can answer the questions based on the result of process. So are the data that have been deleted still giving out the same result? Uh, yeah, in my answer is no. All of the file can be restored in good condition like used to be. In my case, this is the result of the hashes that we can see in this hash list. Yeah, in my Excel. So this is the pre-deleted file, and this is the after deletion. So we can see that the MD5 of the pre-deleted file is uh, 309 EB543, and the hashes of the deletion is 54F7A. Although it giving out the different file names, it giving out the uh, same. Uh, this is the mounting, and this is uh, the USB drive. So as we can see that here, there's this is the original MD5, and the original is HA1, and this is the deletion. So are the data can be have been deleted still giving out the same result? No, because of this result giving out the different. So but it can be reserved and giving out the same MD5 and the SHA1, although it still can be restored. And the next one is, are the data given on the same checksum? No. Uh, this is as we can see, yeah, the MD5 is the original file, and this is the deleted file. So is it are the data given on the same checksum? Is no. SHA1 no. But if we restore it, uh, it will uh, it should be giving out the same result, because the partition, the file deletion and pre-deletion is giving out. The pre-deletion is the key or the role to the hashes. So and that's it from my presentation. Thanks for the video. Have a nice day, everyone.